Alright, we're moving into Math 3. The first thing we're going to talk about is systems of equations. This is section 1.2 on page 6. There's some notes in there, but I'm going to kind of summarize it. Systems of equations, to give you an idea of what they look like, is something like this, and then something like this. So this is an example of a systems of equation. You have two equations going on. You have an x and a y. You don't know either one, and you're asked to find the x and the y. Okay? You have three different methods in order to solve this problem. We're going to talk about each one of the methods independently. The first and hardest method is by graphing both lines. If you graph this line and you graph this line and then you look for the intersection, okay, that is the first and probably the hardest method on systems of equations. Okay? You graph the one line and it looks like this. You graph the other line and it looks like this, and then there's your answer. Where the two lines intersect is your answer. In this case, it would be something like 2, 0. All right? I'm not saying 2, 0 works for this, but you get the idea. You would graph both lines and look for the intersection. Okay? The only problem with that is that lines don't always intersect. Right? If they do, then you have exactly one solution. Two lines intersect, you have one solution. Okay? How could we have no solution? What would be a way that we could not have any solution? What would the two lines look like?
A V.
Not a V, because then they would intersect. They could be parallel. Good. If one line is parallel to the other line, then they don't intersect. Right? And we say that we have no solution. Okay? This is our methods, and over here I'll put solutions. So we can have one solution where we always have an x and a y. Right? There's one solution. We can have no solution, meaning that if I were to graph it, the two lines would be parallel. And then the last case scenario is that we have one line on top of another line. Right? You graph the two lines and they are in fact the same line. So you don't have one solution where they intersect one time. You don't have no solution where they don't intersect at all. How many solutions would you have? Anybody? Infinitely many. Infinitely many solutions. Why? Because look at all the different places that they intersect. Right? They intersect here, 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 all the way down. They intersect infinitely many times. Okay? So these are your three solutions. These are your three graphs that you could possibly have. We have two more methods to talk about. But method number one is graphing. It's the hardest method. Why? Because it's the most time consuming. You got to remember slope and y-intercept. Sometimes you have to use x and y intercepts. It just takes the longest time. If you're off a little bit, if you're not using graph paper, it gets a little confusing. Solutions are the same no matter what method you use. Okay? Whether you use graphing or the other two methods, you either come up with one solution, no solution, which we have a symbol for, or infinitely many solutions. Okay? Infinitely many solutions. Questions on this before I move on? Any questions on this? Your other two methods, method number 2 is substitution. And I don't know how long we'll spend on that because it's a good method some of the time, but it really is kind of spinning its wheels. It's not the easiest method. And then the easiest method is elimination. Elimination, I'll put a little asterisk right here on elimination. Elimination is the easiest method. Sometimes they call it linear combinations. In your book, I don't know what they're going to call it here. Let's see. Algebraically. They may not use the exact same terminology as I do, but you get the gist. All right? So how many methods do you have? 3 methods. How many outcomes do you have? 3 methods. What is the most common outcome? 95% of the time, what happens? You get one solution, right? The 2 lines intersect, and you get one solution, and it's a point. Could be 2, 0. In this scenario, believe it or not, 1, 1 works. Okay, let's check it. What is 1 plus 2 times 1? 3. Let me say that again. What's 1 plus 2 times 1? 3. How about 4 times 1 minus 3 times 1? What's 4 minus 3? 1. So 1, 1. If I were to graph these 2 lines at 1, 1, the 2 lines would intersect. I knew that because I set it up that way. Right? We didn't solve it. I'll show you how to solve it in just a second. But you get the idea. This is kind of an introduction to systems of equations. You have 3 methods and 3 outcomes. Okay? This one happens more often than the other 2. These happen about the same as the other 2. You have 3 different methods. Okay? Questions? All right. Let's see.